be asked per phone call, and that these questions be as brief as possible. You may call the studio directly at the phone numbers or fax which appear on your screen, and we remind you to make your phone calls at a distance from the monitor to avoid feedback. Do we have a first question? Okay. Our first question is from Puebla, Mexico. Go ahead, please.
In terms, this resistance to change is common in educational institutions. What type of quantitative measures can we use to try and combat this resistance? That's our question.
Well, resistance to change is common in lots of institutions, not just educational institutions. And this is where quantitative data can be extremely valuable. If your argument is based simply on your own ideas of how things are changing and how your organization needs to respond to that change, then it's easy to argue that there's no impetus, there's not a real reason to change. If you can show quantitatively that the population has shifted, that there are reasons to make changes, then your argument is much stronger and it's much harder for people to maintain that resistance. But you do have to go out and get the data to back it up. And you have to have good data to make sure that you're making the proper argument. Occasionally you even find out that in fact your sense of something, your belief or your feeling about it, is not entirely correct. And so it's always important to have some kind of quantitative backup, some kind of basis for making your argument for change in any institution, in any direction at any time, so that you have a legitimate argument and aren't just going with something intuitive.
Okay, thank you. And our next question is from Sinaloa, Mexico. Go ahead, please.
If we consider that institutions, such as educational institutions, need to know their target market in terms of age and demographic information, what would be the best way to obtain this information? Thank you very much.
You want to start with knowing what the population is that you serve now. So you would make sure that you have the demographic data on your student population, for example. And sometimes this surprises people because, again, you may have a sense that it's mostly young people at your university, but as is the case in the U.S., many universities are serving a growing population of older adults. So you start by collecting the data on your own, the population you serve now. You can do this through a survey or through a census where you actually collect data on every student. After that, you need to match your population data to total population data. Look at your whole area that you serve, geography that you serve, and see how they differ. See how they are, maybe that you have more students from an affluent class and fewer from lower income groups, and you want to change that, or you want to reach out to groups that are underserved. So you want to start by measuring your own group. Who are you serving? Then look at what the population around you looks like and compare the two.
Thank you. And we go to Hidalgo for our next question. Go ahead, please.
I'd like to say hi to everybody in this multinational network. My question is, what factors should we use to identify in each market? And what are the appropriate marketing techniques that we should use in these type of markets?
The basic demographic factors you want, or the basic demographic factors such as age, gender, in some places you might want to look at race or ethnicity. So you want to look at just the most basic population characteristics. When you're marketing, by knowing who your market is, then you craft campaigns that address issues that specifically interest that particular segment of the population.
Thank you for your questions. Let's now move to the second module of our program.
Previously, we discussed survey methodology, how to create and conduct a good survey. Now, let's turn our attention to some of the information we can get from the data collected. The most basic survey would ask respondents one question, such as, do you own a car? The data produced would simply tell us the number and percent of car owners in the population. We could not determine anything further, such as which age group has the highest rate of car ownership. For marketing purposes, it's important to know the characteristics of the populations being surveyed so that we can make distinctions between groups. Typically, this means also asking questions about the demographics of respondents, such as their gender, age, and household income. Obviously, the larger the sample and the more questions asked, the larger the pool of data collected will be. If you ask 5 questions of 1,000 people, then you must make sense of 5,000 pieces of information. Today, computers and statistical software make this a relatively easy task. But while the computer can organize the data quickly and accurately, there are many different ways of analyzing the results. The analysis you choose depends on what it is you want to know. For our first example, let's look at the population of Mexico by age. First, let's look at the basic numbers of people summarized into discrete age groups. We can get an idea of the relative size of the different age groups, but it's much clearer if we calculate a percent distribution of the population by age. Although you can see from the numbers alone that people under age 15 make up the largest age group among Mexicans, adding a percent distribution enables us to quantify the data more accurately and clearly. We can see not only that those under age 15 are the largest group, we can see that they account for 1/3 of the total population. A distribution is simply the percentage of the total accounted for by each segment. In this case, age groups. You could also calculate distributions based on other characteristics, such as gender, or on multiple characteristics, such as men and women of different ages. Regardless of the way you choose to separate the population, the percent distribution will always add up to 100%. This is one of the most common statistics you will use. If you calculate the percent of the population that owns cars, this is also, in effect, a distribution. The percent of car owners plus the percent of people who do not own cars will equal the total population. We simply don't usually report the percentage of non-owners since the value is implied in the percentage of car owners. If you had only data based on one characteristic, such as age, there would be little else you could do with it except to create broader age categories, such as under age 35 and over age 35. However, businesses generally work with larger data sets, and this allows a greater degree of analysis. Another common use of statistics is evaluating change over time. This adds a second set of data to compare in various ways with the first. The statistics involved are relatively simple, but the amount of information you can obtain is considerably greater than simply looking at the data for one particular year. Let's look at estimates of the population of Mexico in 2000 and projections of the population in 2025. The numbers can give us a general idea of the growth in each age group between 2000 and 2025. But as we saw previously, further analysis is usually needed to produce really useful data. With these two data sets, the population in 2000 and 2025, we can see, for example, how the distribution of the population by age changes over the time period. In this table, we've calculated percent distributions by age for the population in both 2000 and 2025. As noted earlier, this is done by simply dividing the number in the specific age group by the total and multiplying the result by 100. In addition, this table shows the percentage point change between 2000 and 2025. The math is simple. The percent of the population that each age group accounts for in 2025 minus the percent it accounted for in 2000. By producing percent distributions for the two different data sets, in this case, the two different years, we are able to quantify the changing population in a clear way. We can say, for example, that in 2000, 1/3 of Mexicans were under age 15. But in 2025, it is expected that this age group will make up a much lower 23.6% of the population. For companies marketing to niches that rely on these age groups, this is important information. Further, by adding the percentage point change, we note the degree of change in the percentage accounted for by children and young teenagers, negative 9.9%. That is, there is a 9.9% difference between 33.5% and 23.6%. Conversely, we can also see that the percentage of the population accounted for by people aged 65 or older will be 4.9% higher in 2025 than in 2000. Percentage point change is not the same as percent change. Percent change is another way of measuring change over time. One measures the difference between two percentages, while the other measures the degree of change in the numbers rather than in the percentages. Technically speaking, percent change measures the degree and direction of change in a value. Returning to our examination of the Mexican population, we can see the amount and degree of change within each age group and in the total population over the time period we are examining. We can see how the age groups change in comparison to each other and to the population as a whole. This tells us how the age structure of the population is shifting. The population under age 15 shows negative growth, which simply means that it will be smaller in 2025 than it was in 2000. The older population, on the other hand, shows a very high degree of positive growth. Percent change over time is calculated as shown in the example here. The population in 2000 is subtracted from the population in 2025. The result is divided by the 2000 population. This will yield a number smaller than 1, in this case 0.3029. Simply multiply this number by 100 and you get 30.29%, which we have rounded here to 30.3%. This formula can be applied to any two numbers across a time period to calculate a change that is expressed as a percent. Percent changes can sometimes be quite large, as was found among older Mexicans. The number of Mexicans aged 65 or older was expected to increase by an enormous 158.2%. This sort of result is sometimes used in misleading ways. For example, in the U.S., it was, for a period of time, common to see interest groups announcing through the media that older adults were the fastest growing group on the internet. In fact, the data did show a huge percent increase in the number of older adults going online. But the increase was so large because the starting point, the original number of older adults who were online, was very small. Similarly, if one looked only at the percent change in the number of people aged 65 or older in Mexico, the 158.2% growth rate would seem to indicate that this is a market that is becoming enormous. But in fact, we can see from the last table that although the increase is 158.2%, the number of people aged 65 or older will increase to only about 12.8 million, still smaller than almost all of the other age groups. Although the largest numerical increase is found among those aged 45 to 54, the percent increase for this group is much lower than is found among those aged 65 or older, because the starting number is relatively high. In other words, the rate of growth generally slows as numerical values increase. You see this in sales of new products or in the income of new businesses. For example, a product might bring in $5,000 in sales during its first month on the market, increasing to $20,000 in the second month as distribution becomes more established. This is a 1 month increase of 300%. But if sales continue to increase at this rate every month, at the end of the first year, you would have sold about $28 billion worth of this product. This would be an enviable success story, obviously, but it's almost certainly not going to happen. The message here is that very high growth rates or very large percent changes over time almost always indicate that the base is small. And you can be sure that the rate of growth will decline in the future. This is not to say that a population segment with a high growth rate would not be an attractive market, particularly for companies that are looking to target a specific niche. You can be sure, for example, that if you could maintain a steady level of market penetration as the number of people in the segment increases. Your sales would increase concurrently. That is, if 5% of the people in a particular age group buy your product or service, the number of your customers would increase as the age group's size increases, even though your market share, the percent of the group you sell to, is not increasing. Let's look now at some other ways of quantifying sets of data. When we examined the population by age, we looked at a distribution by particular age groups. While this tells us a great deal about the population, there are other measures that can summarize some of its attributes very efficiently, such as the mean and the median. Anytime you have a distribution across categories, as with age, you can calculate the mean and median of the values in the data set. Mean is the statistical term for average. The simplest calculation of a mean, or average, is made by summing a set of values and dividing the result by the number of values in the set. For example, if you want to know the average monthly sales for a restaurant over the course of a year, you add up the sales for each month and divide by 12. An average has the benefit of smoothing out variations in the data. For example, sales of some products tend to be seasonal, with higher sales in particular periods of the year. The average enables you to look at the sales as if they were evenly distributed across the year. In turn, this can provide a good benchmark against which to measure your progress. For example, if a restaurant manager knows that they were able to turn a healthy profit on average monthly sales of $200,000 the first year, sales in subsequent months can be compared to that benchmark to make sure that you remain successful. The median is the midpoint in a data set. This means that half the values in the data set fall below the median and half the values fall above it. While the mean or average does help to smooth out high and low data points in a set, it is a measure that is sensitive to extreme values. The median, on the other hand, is based on the number of values in a data set and is not influenced by extremes. A good example of how the mean and median provide different information about a data set is in the analysis of household incomes. In the U.S. in 2002, the average household income was $61,091. But the median household income was a much lower $45,257. The reason for the difference in the median and mean is the fact that the lowest possible income is $1. But the highest income is theoretically limitless. And in fact, some households do have quite high incomes, as can be seen in this graph. The spike on the right represents the 9% of U.S. households with incomes between $100,000 and $150,000. Altogether, 14% of households had incomes of $100,000 or more. The presence of these high-income households drives up the average, even though they make up a relatively small proportion of all households. The average, therefore, is not as useful a number as the median, since only about 1/3 of all households have incomes that are at or above the average. The median household income, on the other hand, tells us the dollar value which divides the population in half and provides a more meaningful assessment of the financial well-being of American households. Put another way, it's more representative of the values in the data set. The larger issue illustrated by the use of the mean versus the median is making sure that the statistical methodology you choose tells what it is you want to know. As I've noted before, there are multiple ways of looking at the same data set. We can examine a single data set, or we can make comparisons across two different sets of data, as we did when we examined population numbers at different points in time. Or we can look at the distributions of values, such as the number or percent of people in different age groups in the population. The key is making sure that the statistical analysis you choose yields an appropriate measure. Another measurement that many people in educational settings are familiar with is norm-referenced testing. This type of test generally measures broad skills, and individual results are benchmarked against the results for all test takers. Most college entrance exams in the U.S., for example, are norm-referenced, with students ranked according to their performance in comparison with other students. In contrast, criterion-referenced tests are not comparative, but rather simply measure whether or not a student has achieved mastery of a particular subject, as determined by the number of right and wrong answers. An example of this type of test is the GTELP, which is used by the International Training Center to measure English language proficiency. Here, the question one is answering is whether or not a student has learned the material, but there's no attempt to compare the student's performance with that of others. When teachers use norm-referenced testing, they may assign student grades based on the curve, which means the distribution of scores across the students. The students with the highest scores would receive the top grade, with other grades assigned based on their scores relative to those top-scoring students. The term, the curve, is a reference to a graph of distributions in which values tend to cluster around a point. In statistics, there is a particular type of distribution known as the normal distribution, which describes a curve with a shape similar to a bell. Here we see a bell curve, a graph of a normal distribution. There are many things that assume a shape much like this. For example, if you measured the height of a very large number of people, the resulting distribution would look much like this graph. The majority of people fall within a narrow range of heights, centered on a specific value. And as the distance from this center point increases in either direction, the number of people with those heights declines. For example, if you graphed the height of adult women in the U.S., you would have a center point of about 65.5 inches. About 2/3 of women would fall within a range of 63 to 68 inches. Beyond this range, the women at each height declines, with the decline getting sharper the further from the center point that you go. One of the primary characteristics of a normal distribution is the fact that the mean and median are the same. In our height example, the average or mean height of women is 65 inches, and the median is also 65 inches. In other words, there are as many taller women as there are shorter women, and the degree of difference is the same in both directions. Knowing what a normal distribution looks like enables you to become familiar with reading graphed data. If you graph your data and the shape is similar to the bell curve, then you know that the values are roughly distributed around a central point, and that the median and mean will be similar. If, on the other hand, the graph has more data points at one end than the other, then you know that the mean and median will differ to some degree. Statistics may seem intimidating, particularly when you must navigate the jargon of statisticians. But with an understanding of some basic concepts and terms, the dry science of statistics becomes a useful tool for better understanding the world around us. Statistics enable us to move beyond broad generalizations and develop a more detailed understanding of the specific opinions and behavior of our customers. A good grasp of the basics can also help us avoid making